Chapter 6 is going to deal with chemical reactions, and it's just an introduction. And you can see from the table of contents that it's a relatively short chapter. We're going to spend the most time on balancing chemical equations, but before we can balance them, we have to have already done the naming, which we just finished, and we have to be able to identify when a chemical reaction has taken place and know what makes up the parts of a chemical equation. Chemical equations and reactions often give a visual signal, but the reactions are not always visible. So some of the things we're going to look for as to whether a chemical reaction has actually occurred or not are color changes, the formation of a solid, which is called a precipitate, the formation of bubbles, which is the formation of a gas, and heat and or flame produced or heat absorbed. So let's look at an example. What is a clue that a chemical reaction has occurred? And if you notice this battery put here in the water, we end up with bubbles. That's showing bubbles or production of a gas. So that's water actually being turned into oxygen and hydrogen gas. And this one, what is the clue chemical reaction has occurred? We have a pink solution and a blue solution. We put them together, and we end up with kind of a purple. So they give you the the colorless hydrochloric acid is added to a red solution of cobalt-2 nitrate, turning the solution blue. So the color changing is an evidence of a chemical reaction. What is the clue that a chemical reaction has occurred in this one? A solid forms when a solution of sodium dichromate is added to a solution of lead nitrate. This pretty yellow precipitate is formed. That's the solid, so it's evidence of a chemical reaction. Section 6.2 deals with identifying the parts of a chemical equation. Chemical reactions involve a rearrangement of the way the atoms are held together. So in this example, we have methane, which is CH4 added to oxygen. That's going to burn and produce carbon dioxide and water. And at this point, I'm going to tell you that anytime you have a hydrocarbon, that's what this is called. So when you have a hydrocarbon, this could have carbon, hydrogen, could have carbon, hydrogen, oxygen. Anytime you burn it in oxygen, always your products are going to be carbon dioxide and water. And that's one of the things you just have to remember, especially for the test. The reactants are always to the left of the arrow, so the arrow points to the products. The products are to the right. In a chemical reaction, atoms are not created or destroyed, so they just change in the way that they're grouped together. So the same number of each type of atom has to exist on both sides. And we look at this example that they give us. If this is the methane and the oxygen, on this side we started with 1 carbon, 4 hydrogen, and 2 oxygen. On this side we ended up with 1 carbon, 2 hydrogen, and 3 oxygen. Matter can't be created or destroyed, so what we have to do is balance the reaction, which is what we're going to focus on in the next section, so that we have equal numbers of reactants and products. There's something else you need to add to your chemical equations, the symbols or the states. So, for example, we're going to use an S in parentheses for a solid, an L for a liquid, a G for a gas, and AQ is what it means to be dissolved in water or an aqueous solution. So you notice that's added to this chemical reaction. So we have solid potassium added to liquid water. The product then is hydrogen gas, which is H2. It's one of our diatomics, and it's in gaseous form. And you see it burned off here. And potassium hydroxide, which is aqueous. And that just means that in the water, it's not just water, not liquid water. It has potassium hydroxide that's dissociated in it. Let's look at this exercise. When blue light shines on a mixture of hydrogen and chlorine gas, the elements react explosively to form gaseous hydrochloric acid. What is the unbalanced equation for this process? And I warned you about this in the last chapter, that you needed to know how to name compounds in order to be able to write out your chemical equations properly. So what you do is you just have to decode what's in here. When a blue light shines on a mixture of hydrogen and chlorine gas, so those are the things you're going to write down, that and is going to be a plus sign. Remember that hydrogen and chlorine are both diatomic, so it's H2 and Cl2. It tells you that they're gaseous. Not always do they tell you that. When they do tell you, you have to make sure you put it in the equation. I'll show you the example in just a minute. The elements react explosively to form gaseous hydrochloric acid. So react explosively, there's my arrow. The elements react explosively, and it points to the product to form hydrochloric acid, which is gaseous, and it wants the unbalanced equation. So which one of these will it be? So you look and see what they talked about first, what the reactants were, hydrogen and chlorine gas. This is the proper way to write hydrogen and chlorine gas, H2 and Cl2, because they're diatomic. You notice the G's are put here to show the state that they're in, and it forms the hydrochloric acid, which is gaseous as well. So your answer is D. That's all we're going to do for examples. You need to read section 6.1 and 6.2 and be ready with an ink pen and a pencil tomorrow for section 6.3.